Hello friends, in the present video, we will solve a numerical based on stratified soil. Okay, now let us consider a retaining wall. Okay, let me change the thickness. Yeah, let us consider a retaining wall. Okay, and the height of the retaining wall is, let us assume, 6 meter, and the backfill is horizontal, and in the 6 meter of retaining wall, up to 3 meters, we are having one type of soil, and another 3 meter we are having another type. Let us say the water table is at this level. That means in this case we are considering all the cases. So from here to here 3 meter and the another 3 meter. Let us say the properties of the soil will be equal to gamma equal to 18 kilonewton per meter cube, and let us assume angle of friction in this soil will be equal to, let us say, 30 degrees, and also let us assume that C is equal to 0. Okay, now along this, let us say this is not 3.5, let us consider it as a 4.5 meter. We can consider anything. Now here in this part, the saturation weight density, that is equal to 24 kilonewton per meter cube, and angle of friction, let us say phi 2, that will be equal to 20 degrees, and cohesion is equal to 0. So in this case we have to find out active earth pressure acting on the retaining wall. Okay, now what is the difference this one and the previous cases? Only the difference is that up to 3 meters we are having one type of soil, and another 4.5 meter we are having another type of soil. Okay, let us assume 3 plus 4.5, 7.5 meter. So in this case, how do we have to proceed? Okay, now let me draw the pressure diagram here. Sorry. At the top of the soil, hope everyone can say what is the pressure acting on there. Is there any vertical stress there? No. That means there will not be any earth pressure. If you keep on moving below the ground surface, then your vertical stress will increase. That means your earth pressure will also increase. Let us say at 3 meter depth, let us find out at the variation. At your 3 meter depth, if you look into it, if you consider just a point above of it, then just above, very slight, let us assume the distance between is 0.00001 mm. So what is the phi value? 30. If you consider just a point just below the 3 meter, that means just 0.00001 mm below the 3 meter. What is the phi value? 20 degrees. That means at the same depth, just above it, what is the phi value? 30. Just below of it, what is the phi value? 20. That means at 3 meter depth exactly we cannot say it. Why? Because at that level we are having two different types of soils. So that's why what we'll see is that we'll find out that in two different cases. First one is that just above 3 meter. Just above 3 meter. Let us assume the distance between the point and the intersection layer is 0.0000001 mm. Will it considerable? No. Just for the analytical purpose we are assuming. Now, what is the vertical stress up to that layer? This is in dry condition. So what is the vertical stress? 18 into 3. That will be equal to how much you will get? 54 kilonewton per meter square. What about the Ka value? Let us say as we are representing phi 1, I am writing Ka1. That will be equal to, as we are finding active earth pressure, 1 minus sine phi divided by 1 plus sine phi, phi 1. If you substitute phi 1 equal to 30, then you will get a magnitude of 1 by 3. Now, what is the active earth pressure just above the point? Active earth pressure just above the point, that will be equal to find out by Ka into sigma v. That will be equal to, what is the Ka1 value? 1 by 3. What is the vertical stress we are getting? 54. If we solve this, we will get around 18 kilonewton per meter square. So this is the active earth pressure just above the, that means just above it. Just above, what is the magnitude? How much you are getting? 18. So this value is, let us say, 18. And how in between these two layers it will vary? Earth pressure will always vary linearly. Okay, now we will see just below the layer what is the active earth pressure. Let us consider another case, that is just below the 3 meter. Just below the 3 meter. Imagine, do you think your vertical stress will vary here? At the same layer, what is the distance we are considering? We are not even consider 1 mm also. That means vertical stress will vary? No, vertical stress will be same. That will be sigma V. That will be equal to 18 into 3 again. That will be equal to 54 kilonewton per meter square. Now, what about in that region? What about the phi value? 20. So that's why I'm finding active earth pressure coefficient. That will be equal to 1 minus sine phi 2 divided by 1 plus sine phi 2. Phi 2 is how much value? 20 degrees. If you substitute in this equation, then you will get the value around 0.49. Okay, now tell me, what is the active earth pressure just below the 3 meter? That will be found out by using Ka2 into sigma V. What is the Ka2? 0.49 into what is the sigma V? 54. Then we are getting this magnitude as around 26.5 kilonewton per meter square. So what is the difference between just above and just below? Your vertical stress is constant, but what is the difference? Your angular friction is different. If your angular friction is different, then your earth pressure coefficient will also be different. So in the just above the layer, what is the magnitude? 1 by 3. Just below of it, what is the layer? What is the constant? 0.49. So that's why if I represent that value, how much you are getting? 26.5. So just below of it, I am drawing just below of it, but it looks like that I am drawing it on the same layer. 26.5. Now if I see here, it is looking like both are drawing on the same line, right? But if you zoom in, then only you will see that there is very small distance between them. Now, in between, if you keep on moving below the surface, again, your vertical stress will increase. That means your active earth pressure will also increase. Let us find out what is the active earth pressure at the bottom. Up to 3 meters, our soil is in dry condition. After after that, we are having water table. That means your vertical stress that has to be effective manner. So what is effective vertical stress? Up to 3 meter, we are having dry condition. Okay, directly we can take the weight density, but after 3 meter, we are having the water table. There we have to consider the submerged unit weight. What is the submerged unit weight? That is 4.5 into gamma dash. That will be equal to 3 into, in the first 3 meter, what is the weight density? 18 plus 4.5 into, what is the submerged unit weight? That will be gamma saturation minus gamma W. What is the gamma saturation given? 24. What is the gamma W? Let us consider, for simplifying purpose, let us consider it as a 10. So if you solve this, you will get it as a 117 kilopascal. So this is the vertical stress at the bottom. What is the active earth pressure? That will be equal to active earth pressure coefficient at 2 into vertical stress. So this is because of the soil, but again we are having some water content. Because of the water, what is the vertical stress? Sorry, if it is a water, whatever the direction your pressure is constant, that's why it will be gamma W. Up to how much height water is there? 4.5. That will be equal to Ka2 is nothing but a 0.49. Vertical stress is given as how much? So 0.49. What is the vertical stress? 117 plus, we are considering weight density of water is 10 and into 4.5. So what is the active earth pressure at bottom? That will be equal to, if we solve this, we will get it around 316.73 kilonewton per meter. Okay. Now, Let us represent this value here. How much you are getting? 316.7. So the value will be 316.7. And join these two lines by an inclined line. So always it will vary linearly. Why? Because the vertical stress, it is varying linearly. That's why. Now, what is the total active earth pressure acting on the retaining wall? That is nothing but a area of this pressure diagram. What is the area of this pressure diagram? That will be equal to, let me draw it here, okay? Again. So if I draw the pressure diagram again, here it will be 0, 3 meter. What about this weight? Here 18. And what about here? It will be around 26.5. What about the magnitude here? It will be around, sorry, what did I told you? Last value. It is not 316.73. This value is around 102.33. 102.3 kilo Pascal. So this value will be 102.3. Now, what is the height from here to here? 4.5. Now, what is the area of the pressure diagram? If I consider this triangle, what is the area of the triangle? Half into 3 into 18 plus whatever the area of this trapezoid, that will be a plus b by 2 into h. That means 26.5 plus 102.3 divided by 2 into what is the value? 4.5. We will get the active earth pressure, that will be equal to 316.7 kilonewton per meter. That means if you take 1 meter length, what is the earth pressure acting on the retaining wall? 316.7 kilonewtons. Okay, is there any doubt here? So wherever you are having different type of soil, there you have to find out like just above the soil, and also you have to find out it like just below the soil, and then draw the pressure diagram in a similar way. Then you will get the correct answers. In the next video, we will solve a video based on the surcharge. How to find the at the pressure if there is a surcharge acting on the soil. Thank you.